Hi everybody, thank you for watching my video on physics. In this video, we shall discuss an alternative method to measure the specific heat capacity of aluminium. Instead of measuring the heat supplied to aluminium directly, we shall mix aluminium with water and make use of the fact that the specific heat capacity of water is 4,200 Joule per kilogram per degree Celsius. The apparatus needed in this experiment include an electronic balance, a kettle of hot water, 2 empty polystyrene cups, an aluminium block tied to a piece of string, a beaker of tap water, a temperature sensor connected to a computer through a data logger. The overall procedure is to put a hot aluminium block, which we call A, into a cup of cold water, which we call B, assuming that no heat is lost from the system. The heat lost by A should be equal to the heat gained by B. We shall measure the masses of A and B, MA and MB, their initial temperatures TA and TB, and the final temperature T of the mixture. Let C be the specific capacity of aluminium. We have heat loss by A, Q loss, equal to MA times C times TA minus T. Heat gain by B, Q gain, equal to MB times CB times delta TB, equal to MB times 4,200 times T minus TB. By conservation of energy, Q loss equal to Q gain, we have MA times C times TA minus T equal to MB times 4,200 times T minus TB. Therefore, the specific capacity of aluminium is C equal to MB times 4,200 times T minus TB divided by MA times TA minus T. By putting the measured data into the above equation, we can calculate the required specific capacity. Now let's start the experiment. Firstly, measure the mass of the aluminium block. Make sure that the initial balance reading is 0. Put the block gently onto the balance. The result is MA equal to 73 gram equal to 0.073 kg. Next, place an empty expanded polystyrene cup onto the electronic balance. Press the tare button to set the balance reading to 0. Now pour cold water from the beaker into the cup. The mass of the cold water is MB equal to 264 gram equal to 0.264 kg. Next, measure the temperature of the cold water. From the computer screen, you can see that TB equal to 20.3 degrees Celsius. This is also the room temperature. Now place the aluminium block into another polystyrene cup. Pour hot water into the cup. You can see that the temperature reading rises. We have to wait until thermal equilibrium occurs between the hot water and the aluminium block. When temperature falls to 85 degrees Celsius, we shall quickly transfer the block to the cold water. It is important to whip the block with a dry cloth to remove excessive water from it. Also, we need to close the lid to prevent heat loss to the surrounding. Stir the water and wait until the temperature becomes steady. When the temperature stops rising, it should be our final temperature. The final temperature should be T equal to 23.8 degrees Celsius. Put our data into the equation. The specific capacity of aluminium is equal to 0.264 times 4,200 times 23.8 minus 20.3 divided by 0.073 times 85 minus 23.8, and the result is 868.7 Joule per kilogram per degree Celsius. Note that the standard value for aluminium is 900 Joule per kilogram per degree Celsius. Our result is very close to the standard value. Apparently, the experiment is quite successful. In fact, there is heat loss to the surrounding. This occurs when the block is being transferred to the cold water and after the cold water is heated up. This loss in energy should cause the specific capacity to be smaller than 900 Joule per kilogram per degree Celsius. However, since it is unavoidable that there is still hot water remaining on the aluminum block, the string, and the temperature sensor, extra heat is given to the system by this hot water. This gain in energy should cause the specific capacity to be greater than 900 Joule per kilogram per degree Celsius. In this experiment, the two errors compensate with one another. Therefore, luckily, our result is very close to the standard value. In summary, you've learned how to measure the specific capacity of a metal by using the method of mixture. We have also discussed the experimental errors of this method. However, these errors can be further reduced by more carefully planning our experiment. Question: do you think cutting the aluminum block into small pieces will improve this experiment? Can you suggest other ways for improvement? Be the first to write your answer in the comments below. You are welcome to comment on the answers of other people. I hope this video can help you understand more about finding the specific capacity of a metal by using the method of mixture. Thank you for watching.